has in that table she tells us to copy down in our lab notebook? Because I don't know what the difference is between like the actual versus experimental focal length.
So the actual focal length is going to be the theoretical value. So you're going to use equation 2. That's the 1 over d naught plus 1 over di is 1 over f. F is focal length. That will be your actual, and it will always be 4. Well, it should always be 4. But for experimental, most of them will be 4, but some of them will be like 3.99 or 3.999. They're all going to be very, very close. This graph was really intended for using the apparatus in the physical lab, where you would get a little bit more of a different variation between actual and experimental.
So for the actual, then Josh just write 4 for each one, and then for the experimental, we use the values we get on the screen here and plug them into that equation 2.
Yeah, use the values of d naught and di.
Okay.
And they all should be really close to 4, except for the 2 that have a virtual image. Those are going to be a little trippy. So if they look trippy, don't worry. They're supposed to be trippy.
Which value do we write down in the image distance?
So image distance, that's going to be di from your simulation. Does that make sense?
Mm-hmm. And it doesn't matter what our height is at?
Not for focal length. The height matters for magnification.
So how do we know which one to do for magnification?
Say that again?
Which height do we know to do for magnification? Like, which one do we pick?
You're going to need both. You're going to need the height of the object and the height of the image.
Yeah, but like with the object, how you can change it. I don't know how high or how low to go. She just gives you distances, like the object distance, but she doesn't give me like what height to go to. If that makes sense, we have to move that.
It doesn't matter.
Okay.
Yeah, you could pick any height. So you could pick a height of 1 or a height of 2 or a height of 3. I suggest that you put one that's a whole number, because if you get close to it, it'll snap to it and it'll be exactly that height. So if you look on my screen, like I could do a height of 1.43, but that's kind of lame. But if I go close to 2, it'll snap to it and it makes it exactly 2.
We can keep it at 2 for every value of the object distance.
Yeah. I like that. That's actually exactly what I did.
This might be a really dumb question, but for the question that asks, is the magnified image larger or smaller compared to the object, I got negative for my magnification for almost all of them except for the 3.5 and the 2. So what does it mean by larger or smaller? Is that like the absolute value of it, or?
So magnification, it doesn't, the negative or the positive actually has to do with whether the image is inverted or upright.
Oh, okay.
The negative magnification indicates that the image is inverted or upside down.
Okay.
So for most of these, it's going to be negative. Like you said, 10 through 4, you're going to have a negative magnification. But a magnification, like if we take the absolute value, if it's bigger than 1, then it's being magnified. So if you look at my screen, the magnification is -2.
Yep.
2 is greater than 1, so it's being magnified.
So when it says the object, though, does that, like, is that the measurement of the object? So, for example, like 4.5 for my magnification, I got 8.04. So technically my absolute value of my magnification is larger than, like, my centimeters of my object. Is that how I should think about it?
I didn't quite follow all of that.
So for the measurement of, well, what are you on right now? You're on 6. So for my magnification, I got -1.99 by, like, calculating it out.
Okay.
So in this instance, my magnification is, essentially 2, but that's smaller than 6. So when it says, like, is it, oh my gosh, okay, it's just saying if it's greater than 1, it's larger. It's being magnified.
Yes.
Oh gosh, okay, cool, thank you.
So just to give you another example, if you were to look at my screen, you see the magnification is 2.
Yep.
Well, it's -2, so that means it's inverted, which we see that the image is down here in the bottom. But then you'll see the height of my object is 2 units. The height of the magnification is 4 units. It's doubled.
Okay.
Double the magnification, double the height.
Okay, that's super helpful. Thank you.
Sorry I was so confusing. I didn't mean to be.
No, I think I did that myself.
So do we need to calculate magnification, or is that what it's giving us right there?
That is what is given for this M, this capital M, but I can almost guarantee that magnification will be on the quiz, so you will need to know how to calculate it.
Oh, okay. All right.
On equation 3, there are 2 ways to calculate it.
So is it okay if we just write down the magnification instead of writing down the individual, like, height of the object, height of the image? You know what I mean? All those individuals, because those are part of the magnification equation.
That's fine with me. I don't mind.
And then my other quick question was, when she tells us for our object distance to go to 10 centimeters, do we need to be on that left side of that? At the -10, does it matter if we're on the left or on the right? Like, so you have -10.
I would go to -10.
Okay. I wasn't sure if I could be on, like, a particular side.
And this is where it's a little bit deceptive. It starts at the bottom of page 6 and the top of page 7. It's in a sky blue lettering. Those are the sign conventions for lenses and optics. So she says to start at 10, and if you look, the object distance is positive if the source of the light and the object are on the same side. So even though our graph says -10, a distance of +10 means we need to be on the same side as the light, which for this case is the left side.
Hey Dave, could I just ask like one really quick question from an earlier section, but that's like just the one question that I have.
Sure.
Cool. So question 3, in part 1, where it asks about why or the advantage of looking at, sorry, I just need to find the correct wording. Yeah, number 3, what advantages does this provide with like measuring the angle of reflection from both sides of the normal line? I guess I just like don't know what that means.
I really hate how they use the word advantage. Really, there's no advantage to using it one side versus the other, except for that we can verify that it is reversible.
Okay, yeah, I guess I just didn't know what advantage meant, so it's just another means to show that, like, that rule always works, or, like, Is that what you're saying?
That is perfect.
Cool.
Yeah,
Okay.
I had like an hour-long conversation with Dr. Hoskins about how I really hated the word advantage in that question. And
yeah, that makes no sense. As like advantage in what like realm? Like, okay, cool.
Thanks, Dave. I'm gonna hop off.
okay, good luck.
Thanks. Bye.
So in that,
Yeah, me too. Thanks.
Yep, no problem, Sarah.
in that equation where we're supposed to find the focal length, like the 1 over the DO plus 1 over DI,
Yeah.
that gives us 1 over the focal length. How do we flip that back up? Or can we not just do DO plus DI and then y flipped?
Okay, so to flip that, what I would do is I would add the fractions 1 over d naught and 1 over di, and then you'll get some value. Doesn't matter what it is. Then you go 1 divided by that value, and it'll flip it.
Okay, yeah, that makes, I got like 4.02, so.
Perfect. That's a great value.
So I have a question.
Sure.
So I think I wasn't 100% following, but I'm assuming so that magnification value that we're writing down from this, does that replace that thing where she had us write down HI over HO and then DI, negative DI over DO?
Yes, you
Okay,
can
so
totally do that.
We don't
Now
have to calculate that out. That magnification kind of replaces that entire column.
Yeah.
Okay.
So you could write the HI over HO and just like verify that they are the same. And I might recommend that for like 1 or 2.
Okay.
But not for all of them.
Okay.
So we just have to fill out that table and then answer the questions, right?
Yep.
So in question 1, it asks about the lens equation. Which equation is that?
Let's see. I believe that's equation 2.
For the focal length?
Mm-hmm. That's the lens equation.
That's asking like how close you are to the actual.
Yeah, it's the d naught, the 1 over d naught plus 1 over di is equal to 1 over f.
So that's basically just asking us to compare the actual focal length to the experimental.
Yes. Once you fill out that table, you're going to notice that something is a little bit weird. Something is a little bit off. And so you're going to have to say, under what parameters are they going to agree?
Okay.
I have a question for number 2. What does it mean by a virtual image?
All right. So when you do, let's see, I think it's one of these simulations. It might be this first one. A virtual image is, imagine that you're looking at a mirror. Okay, so the actual image is on the mirror, and it's being reflected back into your eyes, and then your eyes interpret it. But a virtual image, instead of being reflected back into your eyes, it's like it goes through the mirror. And there's totally an interactive for it. I know there is.
Do you have an example of that off the top of your head? Because that sounds really weird.
I know, right? Doesn't it sound bizarre? Okay. Give me a moment.
Is that something we can see in our regular lives?
No.
Okay. I just needed you to answer that one. That's it. I just wanted to know if there was like this weird phenomenon I've never noticed before.
Okay, so it's in the first interactive. So can y'all still see my screen?
Yeah.
Okay. So it's gonna make me go through all this jazz. Okay. Let's see. Here we go. So the virtual image, if you look at this, you see these dotted lines, how they're going through the mirror? That virtual image, it's not a real image, it's fake. That virtual image is as if it was going through the mirror. So the real image is bouncing off the mirror, bing, and goes into your eye, and then there it is. That's the real image. But this virtual image, it's kind of fake.
So it's basically like the candles we have to draw in part 1. Like that candle we were comparing it to, that was the virtual image.
So that is an actual image. It's not the virtual image. It's the real deal. You can't really see a virtual image very often. I'm trying to think of one where you actually can see one. I can't think of anything where you actually see the virtual image. But I would run through these interactive lessons, and it will definitely help a lot.
What about question 3? How do we know if it's inverted or upright? Like, it's like I have the sign conventions up. I don't know if that has anything to do with it. Like, I don't remember it saying anything about whether it's inverted or not.
So the best way to tell is if you look at your simulator, it'll tell you whether it's inverted. And why it's inverted is the object, it's in the positive y direction. So see, it's above the line. Our image is below the line. So it's in the negative y region. Now that's going to swap when we get over here. So now the image is virtual and it's upright.
So it has to be virtual to be upright.
Yes, ma'am.
Okay. Would you see like a virtual image if somebody was doing like an illusion or something?
That could be it.
I'm trying to think of how something weird like that would be used for.
Well, let me Google it. Google's not real helpful. I
Story
am
of
gonna.
my life.
So let me put it this way. It doesn't matter right now for this lab. This would be a great question for Burnaby.
Okay.
I'm sorry that's a lame answer, but I don't know.
No, that's fine. I'll go harass her on Thursday.
Yes, she needs to be harassed.
My thoughts exactly.
Did you say that a virtual one, that's when the image is upright?
Yep.
Also, when I was solving for all of my focal lengths, my experimental ones, I got all those numbers to 4. At some point, when I hit 3.5, my image distance became negative, but that still gave me 4. So I don't. Did I do that incorrectly?
So for 3.5 distance from the object, what'd you get for your focal length?
4.02.
And what'd you get it when it's 2?
4.
Interesting.
Because for when I did them, I have it at a height of 2, and if I do it at negative or at 3.5, then my image distance is like negative 28.02. But when I flip it and do like 1 divided by that number, I get like a negative 0.036. And if I divide 1 divided by 3.5, I get like 0.285. So if I add that to like a negative 0.036, I get 0.249. And if I divide that, or like invert that 1 divided by that, I get 4. So it's basically 1 divided by 0.25.
All right, give me a second. What'd you get for your image distance for 2? For the
Negative 4.
So when your object distance is at 2, what did you get for your? Oh my good heavens!
Yeah, I get negative 4.
I think I wrote that down wrong. Give me a moment. You might be totally right. Which, I mean, it's not surprising, but I feel a little bit ashamed and chagrined that I'm wrong.
Are we talking about focal length for 2 centimeters?
Yes. We're comparing the actual to the experimental.
Okay, I get regular 4, not negative 4.
For the image distance, sorry. For the
For
negative.
Oh yeah, I get negative 4.
Yeah. And then Dave was saying that he got some crazy numbers for some of them, but I got just right around 4 for all of the focal lengths that I saw before. So.
Megan, you're totally right. I don't know what I wrote down, but you're totally right. Mazel tov, gold star. I'm just going to triple check, but I think you're totally right. I don't know what I was thinking. Give me a second. You're totally right. Oh my gosh. So the focal length does not change at all. I just put in the wrong numbers and I messed up. You're totally right.
I can't remember what did you say. I was trying to answer on number 1 that asks about agreement with the lens equation. You just explained this, but totally went out of my head.
So, yes, they are totally in agreement.
Yeah, okay. So I asked you if I was going to be comparing the actual experiments on my Okay.
For question 4, I'm not really understanding my magnification data. Can you explain that to me before I attempt to answer this question?
Sure. So go ahead and look at my screen. So I'll start. I'm going to start right there. Okay. So right now the magnification at 10 units away from 0 is negative 0.67. The negative means that the image is inverted, so we understand that, and that's okay. The 0.67, though, means that right now the actual image is smaller than the object. It is not being magnified. It's being shrunk. Now, as we move closer, I'm going to move to 7 units. It's still negative, which is what we expect. It's inverted, but it's 1.33.
Okay, so the negative doesn't actually have to do with how big the value is. Okay.
No, the negative only has to do with whether or not it's inverted or upright.
And then it looks like. Oh, sorry. Go ahead.
Just like if you move this past the focal length, you'll notice the magnification becomes positive.
Yeah.
Because it's
But
upright.
then you also hit that sweet spot where it starts getting smaller again. At least that's what happened with me. I might have written it down wrong, but for 3.5 I got 8.01, and then for 2 I got 2.
Yeah, I got that too.
All right, say that again.
So for 3.5, object distance of 3.5 centimeters, I got a magnification of 8.01. And for an object distance of 2 centimeters, I got a magnification of 2.
I think that's right. So magnification of 2 when the object is at 2. Yeah?
Yes. So looking at that pattern, if we increase the object distance further, it's just going to get, the image is going to get smaller again.
Yep.
And then if the object distance is really big, maybe we just don't even see the image.
Yeah, it approaches 0, the size. It gets really, really, really little.
So on number 4, I don't know if she was asking about this one, asks if it's larger or smaller. Does that have to do with the negative values at all for the magnification?
For that one, you're going to have to say for what distances for the object is the image larger and which one are they smaller.
Mm-hmm.
So like right now at 10, it's smaller. And at 9, it's smaller. At 8 is the same size.
Okay.
7, it's bigger. 6 is bigger. So you can write down these distances, it's smaller. These distances, it's bigger.
Okay, gotcha.
Just really quick, for question 1, it says, are your results in agreement with the lens equation? Should I just say yes, because when I plugged my numbers in, they matched my actual and my experimental?
That's a great way. I liked it. Yep.
Okay.
So on that number 4 again, on 3.5 and 2, I got negative values for my image distance. Does that mean it's smaller than the compared to the object?
Hold on, say that again.
So for that question, you're saying we had to compare the distance lengths that are on the screen, right? So
which question is it that we're looking at?
Number 4, the one I was asking you about.
Oh, so here you can look at my screen again.
Yeah.
If magnification is less than 1, like the absolute value is less than 1, then the image is smaller.
Okay.
So kind of ignore the negative for a little bit. Think, is 0.67 smaller than 1? Yes. Therefore, the image must be smaller.
Mm-hmm. So for 8, when it's at 1, they're the same, and then everything after that is greater than 1, so it would be larger.
Yeah.
When we're talking about image distance, is that image size? I just reread the question and I was like, oh.
Yeah, it's image size.
Image distance is image size?
Well, for number 4.
For 4 and for 5? Not 4? What would happen to the image distance if you increase the object distance even further?
It would get smaller, right?
Oh, I read it the same way you did. If the object distance is huge, then the image distance is huge. Oh man, where's my math? If the object distance is huge, then the image distance is tiny. Tiny. It approaches 0.
Okay, that's... So 5 and 6 are basically like the same question. Just one's more exaggerated than the other.
Let me double check. Yeah, they're the same question, but exaggerated.
Okay.
Okay, that answers all my questions for tonight. Thanks for your help.
No problem. Have a good night.
You too. I might pop in on Thursday if I find something wrong, but I think we're all good. So.
Okay, if you have any questions, feel free to come by.
Awesome, I will. Thank you. See you guys.
Yeah, that was all my questions as well. So thank you for all your help, Dave. You're a saint.
No problem, Megan.